So hello friends, in this video I will discuss about solution of this particular example. Now here if we look at the problem statement, so what is asked is to firstly write applications of Thevenin's theorem, which will be followed by you have to figure out what will be the current which will pass through 2 ohm resistor. Now here what will be this current. Now in a first look, it seems to be like we can solve this example using node analysis, mesh analysis, any method, right? But in this particular example you do not have to use mesh analysis or node analysis. You have to solve this given example using a Thevenin's theorem, and we know that in what Thevenin's theorem state, like if you have to figure out the current which is flowing through 2 ohm, you have to consider this 2 ohm is a load, and across this 2 ohm resistor you have to find out the Thevenin equivalent. So what I did is I assigned AB terminals. So while going through the steps to figure out Thevenin and Thevenin, finally AB would be connected across Thevenin and Thevenin, across which I will connect 2 ohm resistor, and then my loop current is I. Now in order to find this current through this 2 ohm, I will be simply my Thevenin upon Thevenin plus 2. So in this way we have to calculate current. Now it is very much clear that firstly we have to figure out Thevenin, we have to figure out Thevenin. Alright. So what I will do is firstly I will open this 2 ohm resistor, and then my circuit will look like this. After opening this load, there will be only current in the first loop and there will no current in the second loop. And yeah, we have to firstly find out current I, and for that what I can do is I can assign current like this, and I can assign a sign also across all the resistor. Now the drop across 5 ohm and can be calculated as per Ohm's law, V equal to IR. Current flowing through this 5 ohm and 10 ohm are is a common, means I. So I, and in case of 5 ohm, phi I will be the voltage drop. In case of 10 ohm, 10 I will be the voltage drop. So I can assign this voltage drop like phi I and 10 I. Then I need to write equation using Kirchhoff's voltage law. So if I start from this point, minus to plus, my voltage will increase. So plus 40, and plus to minus means reduce. So minus phi I, and plus to minus means reduce, minus 20, plus to minus means voltage is reduced. So minus 10 I will be equal to 0. So 20, 40 minus 20 means 20, 5 and 10, so minus 15i is equal to 0. So 15i is equal to 20. So I would be equal to 20 over 15. So 4 over 3 ampere. Okay. Now in order to find this Thevenin, we have to go through this loop. So if I start from this point, so plus to minus means minus 10i, then so this current is 4.4 over 3 that we have figured out, right? And then if I move in this direction, then my plus to minus, so again minus 10, then minus to plus, so it would be Thevenin is equal to 0. So Thevenin will be simply 10i plus 10. So if I substitute I is equal to 4 over 3 plus 10, so 10 times 4 means 40, and 3 times 10 means 30 divided by 3, so 70 by 3. So this is my Thevenin. Now the second part we left with is Thevenin. So in order to find Thevenin, what we have to do is we have to simply replace all the voltage sources. If you recall, like firstly we were having 40 volt source here, then 20 volt over here, and 10 volt over here. So what I did is I simply short all those voltage sources, and then this equivalent circuit look like this. Okay, like after doing this shorting this 40 volt and 20 volt and 10 volt across AB, I have to figure out R Thevenin. Now if I redraw this AB terminal, so these two resistor are in parallel, one is 5 ohm and 10 ohm. So R Thevenin across this is parallel combinations of 10 into 5. So 10 into 5 upon 10 plus 5 means 50 over 15. So that would be near to 3.33 ohm. Alright, so we have worked out Thevenin, which was 70 over 3 means 23.3 volt approximate, and the resistance is 3.33. So finally we have simplified this whole circuit and we have converted into Thevenin equivalent, where Thevenin is 23.3 and R Thevenin is 3.33. So my current which is flowing through this 2 ohm will be simply Thevenin over R Thevenin plus R, which would be equal to 23.33 over R Thevenin 3.33 plus 2, 23.33 over 5.33 will be equal to 23 over 5.3, 4.37, right? So it is 4.37 amps. Now we can cross verify the answer with LT spice simulation. So I made the same circuit. After running this, if I look at this current, so you can check like 4.337 ampere.